Okay, so I am recording, so those folks watching at home play along. So key terms, factors, big deal. Factors are a big deal. These are two very important terms. Okay, we talked about factors before. Okay, factors are the individual pieces of the product, like 2 and 3 are factors of 6. 2 times 3 gives me 6. That makes them factors of 6. If I have a polynomial, factors might look like 3x times 2x minus 3 times x minus 5 equals 0, where 3x, 2x minus 3, and x minus 5 are factors. We've done this already. Okay, when we were looking in the last chapter, this is one of the things we dealt with, was factors. We had factors, solving for factors. Okay. Solutions. This is also a big deal. Solutions are where my zeros are. Solutions are my roots. Solutions are my x-intercepts. They are all the same thing. Different ways of saying the same thing. Basically speaking, if I have a graph, something like this, anywhere that graph crosses the x-axis is a solution. Okay, that's where my zeros are. It's a big deal. If we go back to this, this is exactly what they were doing. Take the derivative, set it equal to 0. You need to know where the zeros are. Factored it out. Set each factor equal to 0 to find the zeros. This is why these are the important points. These two, 0 and 3, are actually called critical points. That's the technical name for them. They are the critical points. How do you find them? They're the zeros. How did I find 0 and 2? They're the zeros. Take the second derivative, set it equal to 0. That's how important this stuff is. That's what they do. My calculus students' mantra for chapter 4 is take the derivative, set it equal. When in doubt, take the derivative, set it equal to 0. Find the zeros. It's a big deal. Most of what you try to do in mathematics is find the solutions, i.e. find the zeros, find the roots. Okay, it's a huge thing. We spend a lot of time doing it. We've already spent a lot of time doing that. Okay. Now, sketch the zeros and determine the equation. So, this is a two-part problem. Part 1, sketch the zeros. Well, remember our zeros are the opposites. So I have a 0 at 2. And let me go ahead and change colors. Put color on here. Oh, black and white. So I have a 0 at 2. And I have a 0 at -6. Okay. And the other thing I want to do is I need to determine the equation. In other words, write it in standard form. This is in factored form. We need to write it in standard form. So what do? We FOIL. X times x, x squared. X times 6, 6x. -2 times x, -2x. -2 times 6, -12. Combine up my like terms in the middle. Get y equals x squared plus 4x minus 12. This is a parabola, so it looks like that. Where are my zeros? My zeros come from my factors. And remember the opposites of the insides. FOIL it out. That's my equation. That's what it looks like when I graph it. The next one, my zeros on this one. From this, I get a 0 at 6. From this, I get a 0 at -1. And from that one, I get a 0 at 2. I have 3 zeros. Okay. Now I need to multiply it out. I can't multiply it all out in one step. I need to do it in 2 steps. First step, pick 2 of those 2 things and multiply them together. Okay? Might as well pick the first 2. X squared plus x minus 6x minus 6, which gives us for this first part x squared minus 5x minus 6. That is strictly just the first two multiplied together. Now I need to take this times the last term, x minus 2. How do you do that? I hear you asking. Very easily, I answer. Whenever I have more than two binomials multiplied, if I have two binomials, I FOIL. If either one of the things I'm multiplying has more than two terms, I don't FOIL. Now, there are those that distribute, which means I take x times every one of these terms, negative 2 times every one of those terms, and combine up like terms. I like to organize a little bit better. I set up a box. Literally a box. Why do I have it as a 3 by 2? Why is it 3 by 2? Because one of them has 3 terms, the other one has 2 terms. Line up the 3 terms and line up the 2 terms over the tops of the boxes. So I have x squared minus 5x minus 6 and x minus 2. Remember filling in a multiplication chart when you were a kid? Multiply the two numbers, that's what goes in the box. That's what you do here. You multiply the numbers, put what's in the box. X times x squared gives me x cubed. X times negative 5x is negative 5x squared. X times negative 6, negative 6x. I just did x times every one of those terms, put it in the box. Negative 2, same thing. Negative 2 times x squared, negative 2x squared. Negative 2 times negative 5x is positive 10x. Negative 2 times negative 6 gives me 12. And here's the thing I really like about this, is now I just have to combine up like terms, but all the like terms are on diagonals. These are like terms, these are like terms. So I have x cubed, so I get y equals x cubed. Negative 2x squared, negative 5x squared, minus 7x squared. Then on the diagonal here, I have 10x and negative 6x, gives me plus 4x, and then I have plus 12. If you do it like this, your diagonals are always like terms. If I have a if I have a trinomial times a trinomial, I set it up the same way. My diagonals are like terms. I may have 3 like terms that way, or 4 like terms. I've done 5 by a 6 before. Keeps you organized. Make sure you get everything done this way. That's why I like it. It keeps it organized. I don't miss anything when I do this. Does that make sense? Because one of the biggest mistakes students make is not remembering to multiply together something. Okay? So that's my answer. Now, if we go back up to the top, didn't sketch it in, but I know where the zeros are. This is a cubic. It's got that John Travolta thing going on I was talking about the other day. Because it's positive x cubed, it starts down and gets bigger. It'll look something like that. If this was my calculus class, we would find out where this point here is, and we would find out exactly where that point there is. We're not at that level. I don't really care for you guys at that point. That is more than good enough for anything we're going to do here. Okay. Questions so far? Okay, last one, same idea. This one's actually easier to multiply. Let's do the zeros first. What's my 0 for this one? Give me 4. What's my 0 for this one? Negative 7. What's my 0 for the first one? 0. What am I adding or subtracting? Nothing. If I have x all by itself, then its 0 is right there at the origin. That one passes through the origin. Now, when I multiply this one, I don't have to set up a box, even though there's 3 terms, because one of my terms is just plain old x. Foil these 2 parts out here first. So x times x, x squared. X times negative 4, negative 4x. 7 times x, 7x. 7 times negative 4, negative 28. And I'm going to move down to the bottom because I'm running out of room. Y equals x times, all of this is x squared plus 3x minus 28. And all I have to do is increase the power by 1 or multiply through by x. So x times x squared, x cubed. X times 3x, oh, that's 3x squared. X times negative 28, negative 28x. It's really easy to multiply by x. Whatever x's you have, the power increases by 1. If you have a term that doesn't have x, just slap an x on the end of it. It's really easy to do that. Questions? Your turn. Looks like enough time has passed and people know what you're doing. So the first one, my first 0 is a 4. On the second one, it's negative 5. If I FOIL this one out, y equals x squared plus x minus 20, which you'd have to simplify it. Okay, FOIL that out, combine it like terms. This is a nice simple parabola. Something like that there. Okay, on the next one, I have zeros at negative 4. Oh, wait. Let me make an adjustment here. Negative 6, negative 4, and at positive 1. And if I FOIL out the top part, I get x squared plus 3x minus 4, and multiply that times x plus 6. Do you see how I'm getting the shortcuts? I mean, if you FOIL it out and combine up like terms, you get the same thing. I just combine up the middle terms, but there is a shortcut to doing this. If you have x and x, if it starts with x and x, it's easy enough. My first two terms are x, I multiply them, I always get x squared. My middle term comes from adding those two numbers together. 5 minus 4 is 1, so I have 1x. My last term comes from multiplying the two numbers. So when I did this one here, I get x squared because it's x and x. 4 plus negative 1 gives me 3, so I have 3 x's. And then negative 4 times negative 1 gives me negative 4. It only works, you can only do that if it's x and x. If you have like 2x or 3x or something in the beginning, you got to FOIL it out and combine it like terms. It's actually easier to FOIL than to try to do it in your head. Okay, but if you FOIL it and combine it like terms, you get the same thing that I did. Okay. And then multiply that times x plus 6. And I do not try to do this one in my head unless I absolutely had to. I still set up a box for this one. Squared 3x minus 4. So I get x cubed, 3x squared minus 4x, 6x squared. 3 times 6 is 18x. 4 times 6 negative 24. So my final answer, y equals x cubed. And then 3x squared and 6x squared gives me 9x squared. And negative 4x and positive 18x gives me 14x. And then minus 24. And it'll look something like that. Put it in the box, the diagonals give me like terms, combine it with like terms. Last but not least, the x in front gives me an x at 0. X minus 3 gives me a 0 at 3. X plus 2 gives me a 0 at minus 2. If I multiply the x minus 3 times x plus 2 using this shortcut, I get x squared. So I get y equals x times x squared. Negative 3 plus 2 is minus 1, so I have minus 1x. Negative 3 times 2 is minus 6. And I multiply the last two, that's what I get. Multiply those times x, y equals x cubed minus x squared minus 6x. And once again, it's a cubic equation. They're all positives, so it's going to do this. I don't know how high up or how low it goes, but it's going to look like it.
Wait, when do we know how it goes? Or how do we know?
Power. Cubics always start, they do that John Travolta thing. You know, so I know I'm dating myself. I know I am. Do you know what I'm talking about when I say that? John Travolta, Saturday Night Fever? Okay, I will pull it up later to show you pictures so you know exactly what I'm talking about. But yeah, cubics do that. And then the squares or parabolas. Okay, I'm not going to have you, I probably won't have you do anything higher than that. Okay, but here's a little trick. If you are doing this, it's really nice if you look at the degree of the polynomial. If it's an even degree, they look like both ends go up or both ends go down, depending upon if the first term is positive or negative. There may be squiggly stuff in the middle. Get it, squiggly stuff in the middle. But both ends do this. If it's an odd power, if it's an odd degree, it'll look like this or like this. It'll look like this if the first term is positive. It'll go like this on the ends if the first term is negative with squiggly stuff in the middle. See, squiggly stuff in the middle. But x to the fourth power looks something like this. It may have some extra humps in there, but it looks like that. X to the eighth looks like this with some stuff in the middle going on, but it looks on the ends just like a parabola. And if it's like to the fifth power, it'd look like this with an extra couple of humps in the middle. Probably. Not always. Kind of gets weird what goes on in the middle. You don't know for sure, but you know what the ends look like. Okay. Ooh, you done? Perfect timing, because I didn't want to do this while you were doing that. Because now we get to factor and find our zeros from our factoring. Okay. So our factoring comes in a couple of steps. These are all very similar here. They're all cubics, which means I'm going to have 3 roots. What's nice is with all of these, because we haven't gotten any deeper than that with the cubic for factoring purposes, they all have a common factor first. Every single one of these, the first thing I'm going to do is pull out an x. First thing I'm going to do is pull out an x. So we get y equals, and actually I'm going to scroll down and do it down underneath because I can extend the page and give myself a little more room. So I pull out an x and I get y equals x times, I take an x from every term, I get x squared minus 2x minus 15. Okay. I'm not done factoring, but I've begun my factoring. Okay, does that make sense? Now I have to factor my quadratic. Now, you can set up an X box for this. Works every time. Negative 15, negative 2. 2 numbers that multiply to give me 15. 5 and 3. Subtract them, I get negative 5 and positive 3. So my factors are x minus 5, x plus 3. And I'm going to go and scroll up. And I'm going to rewrite my whole factored answer here, just so I have it up at the top. X minus 5, x plus 3. Okay. Where are my zeros? Yeah. I get a 0 at 0. Second term, I get 1 at 5. Last term, I get 1 at negative 3. It's a cubic. It does the same cubic thing. Comes up, goes through, goes down, goes up, looks something like that. The humps in the middle do all kinds of weird stuff. They go up really high or not really high. It depends upon the equation. Each one's a little different, but it has this basic look to it. Okay? Second verse, same as first. Pull out my x. Got to get rid of my x's. Always want to get my x out of there. Somebody gets it. Then I want to factor that quadratic. So negative 12, negative 1. 2 numbers multiply to give me negative 12, subtract to give me negative 1. 4 and 3. Negative 4, positive 3. So I get y equals, and I'm going to, once again, I'm going to go ahead and scoot up to the top. Y equals x times, and I got minus 4 and plus 3, x minus 4, x plus 3. So my zeros, and I like to work left to right when I do my zeros, so I don't skip anything. I don't like to skip around. I have one at 0, one at positive 4, and one at negative 3. And then we go up and come down and go up again. So it looks like that. Same thing, one more time, just to make sure you comprehend what's going on. My first step is to get my x out. Pull out the common x. Y equals x times x squared minus 4x plus 4. Ooh, this is going to be an interesting one. I like this one. This one's interesting. Okay. Two numbers that multiply to give me positive 4, and when I combine them, I get negative 4. Negative 2 and negative 2. Negative 2 and negative 2. So my factors, y equals x times x minus 2 times x minus 2. Is there another way I could write that? X minus 2 squared. Y equals x times x minus 2 squared. Now, I would not require you on a test to write that as x minus 2 squared. I'd love to see it. It would make me happy. It'd make my heart sing. Not a lot, but a little bit. Okay? But I would enjoy that if you saw that and made that change. Okay? How many zeros do I have? I've got 3 zeros. Where are my zeros? I get 0, right? For my x, I get 0 at 0, and then I have another 0 at 2, and then I have another 0 at 2. 2 is a double 0. 2 is a double 0 because that factor x minus 2 appears twice. So I get a 0 at 2 for the first time it appears, and I get a 0 at 2 for the second time it appears. X minus 2 is a factor that appears twice, so that 0 is called a double 0. Because I have x minus 2 twice. I get 2 is a 0 twice. Called a double 0. Might be a triple 0. Okay, I've seen bigger than that, but it's called a double 0. How do I graph it? I've only got 2 places. I don't have 3 like the rest of them where it crossed. Here's how these look. Comes up, goes down and touches, and comes up again. It doesn't actually cross. With a double 0, it doesn't actually cross, it just touches. So if that double 0 is the first number, first factor, on the left to right, it just come up and touch it, go down, and then come up and go through. But a double 0 like this, it just touches the line, it doesn't cross the line. Because we don't want to. Okay, let's do these. So when I factor the first one, I get y equals x times x plus 3, x minus 2 for my factors. So I have zeros at negative 3, 0, and 2 comes up, goes down, goes up. Next one, y equals, factor out an x, and then my other factors are x minus 2, x minus 5. Negative 2 times negative 5 gives me 10. Negative 2 plus negative 5 gives me negative 7. So my factors are 0, 2, and 5. Comes up, goes down, goes up. And then the last one, y equals x squared. Pull out the x squared, and then I get 4 and 2. X minus 4x plus 2, yeah. So my zeros are negative 2, 0, and 4. And 0 is a double root. I have 4 zeros. X squared, because it's x squared, 0 is my double root. Now, it's a positive one, x to the 4th, so it's going to look like this. So it's going to come down Going to come down and go through, come up and touch, go down and go up and touch. X to the fourth kind of look like W's, usually. But remember, the ends, because it's the fourth, it will go positive to the fourth power, because both ends will go up with squiggly stuff in the middle. Okay. Questions? Ooh, determine the standard form of the equation with the roots listed. I'm not going to worry about graphing this one, but I do want to come up with the equation for it. Here's what you do. I need to come up with my roots. I need to come up with my factors that give me those roots. What factors give me these roots? So when x equals these, that tells me I cross it here in -4 and 6. Those are my zeros. That's where it crosses at. Now, don't assume any of them are double roots unless they give you 2 of them. Okay. Then you got to just figure out what my factors are. Well, my factors, y equals, for the -4, I have x plus 4, always the opposite inside, x plus 4. I heard a couple people say that. For the 0, I have just what? Plain old x. And then for the 6, I have x minus 6. Now, this is not standard form. Remember what standard form was? You got to multiply it out. You have something x to a power, and the powers go down as we go on from yesterday. Remember that? Okay, that's what we have to do. So we have to FOIL this stuff out. Multiply it out. So when I multiply it out, I'm actually going to multiply the first factor and then the second factor. I'm going to take the x for last. So y equals x. I'm going to take this puppy, move it up to the front. And then I'm going to multiply the other two. Using this shortcut I just talked about, I get x squared, 4 minus 6, negative 2x, 4 times negative 6, minus 24. Okay. Now, I'm not done yet, right? I have to multiply through by x. Y equals x cubed, minus 2x squared, minus 24x. Excuse me, is that in standard form? Yeah, standard form. We're good to go. Next one's a little more difficult. We have roots at 1, 3, and 5. Like I said, I'm not worried about graphing at this point. I think we've done enough of that. At this point, you got the idea what's going on. If you want to go through and graph it back later, whatever, knock yourselves out. I really don't care about that. I care about coming up with the equation from the solutions. Because that's what we're doing. We're coming up with the original equation that has these solutions. These are my zeros. This equation has zeros at -4, 0, and 6. Whatever we come up here is the original polynomial. We're actually kind of doing the opposite of what we've been doing. Okay, does that make sense? So, my factors. Y equals x minus 1. Y equals x, and then I have x minus 3, and then I have x minus 4. And I take the first two, I'm going to multiply 2 of them together, and then take that times the third one. Yes?
It's 5.
Minus 5, thank you. My bad. It's only my second screw up of the day. That's not too bad. Not bad. Little minor mistakes, but thank you for correcting me. So rather than multiply times x minus 1, because that's really easy, I'm going to multiply the last two together first. So I'm going to take the last two, I'm going to take these two and multiply them. So you get y equals x minus 1 times, multiply those two, x squared minus 8x plus 15. Add the two to get the middle term, multiply the last two numbers to get the last term. Now I have to multiply by x minus 1. Extend the page. Set up a nice little box. Okay, maybe not so little. X negative 1, x squared minus 8x plus 15. And there's a reason why I picked x and minus 1, because they are really easy to multiply by at the end. And I'm multiplying a lot of things by x minus 1 instead of just one thing. Does that make sense? I'm taking the bigger thing times x minus 1. But this is really easy. X times all of these, x cubed, negative 8x squared, plus 15x. I don't need the 15 in front, or I mean the plus, but I already just put an x on everything, increase the power by 1, throw an x on the end. Multiplying by negative 1. That's really even easier. Just change the sign of everything. Negative x squared, positive 8x, negative 15. That's why I picked x minus 1. The only binomial easier to multiply by than x minus 1 is x plus 1. Really. The only one that's easier.
Or 0.
No, that's not a binomial. Combine up the like terms on the ends. Y equals x cubed. Negative x squared, negative 8x squared gives me negative 9x squared. 8x plus 15x gives me plus 23x. Thank you. A little slow. Minus 15. Okay. Questions? Okay, now this next one, I strongly suggest that you guys use the margins. I'm not going to be able to use the margins because there isn't enough room in the margins for me. My zeros are at negative 2, negative 1, 0, 1, and 2. Which means my factors are, and I'm going to do it down here, extend the page. I'm going to do it down here because this is where I'm going to have room. Y equals x plus 2, x plus 1, x minus 1, x minus 2. Yay. Watch closely as I perform my mathematical magic. Multiplication is commutative, which means I can rearrange this into any manner I wish. Moving the cups around, my mathematical magic, I'm moving things around. Where's the magic ball? Doesn't matter. But I can rearrange things. It's commutative. Doesn't matter the order if I'm multiplying. I can multiply them in any order I want. Here's what's really cool. X minus 1 times x plus 1.
Yeah.
Plus and minus are exactly the same except for plus and minus. That's x squared minus 1. Square the first term minus the square of the second term. Because when we factored the difference of squares, what did we get? We got, if x squared minus 1 factored was x minus 1 times x plus 1, right? Square root of each. Same thing for x plus 2, x minus 2. If it's exactly the same except plus and minus between the two terms, for this one here, x squared minus 4. They're like the conjugates. The middle term doesn't show up. Square of the first minus square of the second. Extend page to give myself some more room for my mathematical magic. Are you amazed yet? Get over it. That's my magic working on you. All the blood is rushing to your brain. So to work your brain through mathematics so your extremities are getting cold. Nobody believes me. Nobody ever believes me. Okay. Here's something else that's really cool. What do I have? I have two binomials. If this was x minus 1 times x minus 4, you can multiply that really easy, can't you?
Isn't that
it would be x squared minus 5x plus 4, because you do the middle term. But because it's x squared, it's also really easy. X to the 4th minus 5x squared plus 4. If I were to multiply, if it was x to the 1st power, I'd get x squared minus 5x plus 4. But because I start with x squared instead of x in both terms, I just double my exponents. Now, you can FOIL all this stuff out any way you want. You're still getting the same answer in the end. Long way to go around. X to the 5th minus 5x cubed plus 4. Because x times x to the 4th is x to the 5th. X times x to the 5th, x to the 4x. My bad. Thank you. Doesn't count as a mistake because I hadn't finished yet. I didn't write down something wrong. I just didn't write something down. Right? You want to know what the graph looks like?
Sure.
Only I sincerely doubt that the hoops in between are all at the same level. Probably goes really down and really high, and they're all at different places. It looks really fun. The numbers in between. When you get to here and you're multiplying out, the difference is the more stuff you have in here, the more out of balance it is. Okay. It's one of those things. It's hard for me to predict. I can predict where it's going to cross. I can predict where the highs and lows are going to be. I can't always predict how high and low they are. I can figure it out, but I can't predict them by looking at the equation. Okay, does that make sense?
And our next sections are we going to figure out?
Okay. No, that's what my calc students did. There is a way to do it. You're not ready for that yet. Okay, last ones. Okay, bless you. Let's finish this up. Y equals x, x plus 1, x minus 3 are my factors. Opposite of the roots except for 0, because the opposite of 0 is 0. Doesn't really matter. And when I multiply it out, I get x cubed times, or x cubed minus 2x squared minus 3x. Question? I didn't show my work. I know. Sorry. But if you guys get the right answer, you match. You get the right answer, right? Okay, so it doesn't really matter. I'm making the assumption that you know what to do. If not, feel free to ask, and I will show you. Okay, feel free to ask at any time, almost any time. Next one, y equals x plus 4, x minus 2, x minus 4. And I'm going to take a couple of steps to do this one, x squared minus 16 times x minus 2, because x plus 4 times x minus 4 gives me x squared minus 16. And then I multiply those two out, y equals x cubed. Let's see, minus 2x squared minus 16x plus 32. All right, match. Good. I felt pretty good about doing that one. It was a tough one to try to do. Okay, let's bust out the last one here. Okay, here we go. Y equals x times x plus 3, x minus 3, x minus 1. Okay, those are my four factors. I may not have them in the same order you have them in, but those are the four factors. Order does not matter at this time because we're not putting it in standard form. It's just factored form. Factors don't matter. It's the order. Y equals x squared minus, well, actually, let's do this. Let's do this. x times x minus 1 times x squared minus 9, multiplying the x plus 3 times the x minus 3. And let's extend the page to get some room, slide it up. I'm going to actually do it over here. Y equals x times x cubed minus x squared minus 9x plus 9. So y equals x to the 4th minus x cubed minus 9x squared plus 9x. We good? Does that match? I hope. Saw a couple of nods out there. Good. Questions? Okay.